Shall I open up? So I'm Lindsay Armstrong. I'm a lecturer at the University of Southampton, specifically on the mechanical engineering course, but I also have a role on the admissions team in getting some of the potential students into our courses. That's okay.
My name's Jess Burrell, and I've put together a little bit about my academic journey because the big message that I think is really important to share with everyone is that it's not necessarily straightforward. So in A-levels and that sort of stage, you're making what you think, what is kind of the sort of biggest, most life-changing decision you've made until that point consciously. And I remember how scary that was. But also that decision, there's so many other opportunities to make decisions, and I think that's my big message is don't worry if you can't see a straight line forward. There'll be lots of interesting things for you to go on to do. So I'll start with an example of my GCSEs. I had all the compulsory ones that you had to do, maths, English, and sciences. And then for my choices, which you might think is a bit strange for an engineer, I did expressive arts, French, Spanish, and text arts. So, like I say, it's not straightforward. For my A-levels, I actually went through 2 iterations of choices. So the first ones that I thought I was going to do when I was going around to all the teachers and talking to people and saying what I'm interested in, what should I do, I actually came out with French, Spanish, biology, and film studies. And then I spent a long time talking to admissions tutors and things at universities. I just rang them up and had conversations with them, and I also spoke to different teachers at school about what I was interested in. And I got this bee in my bonnet about a sustainably powered car. I thought, I really want to solve a problem like that. That sounds really fun. And it transpired, if you have chemistry, physics, and maths, then you can do pretty much any science or engineering or technology degree. So in the end, I morphed from my double languages, biology and film studies, into Spanish, chemistry, physics, and maths as my actual final choices. Might come up. They'll be there eventually. And then I took a gap year because I had the opportunity to do so. I did a combination of working and travelling, so I worked in my house in France. I did some working at home where I'm from, and then I did some travelling as well. Went trekking and volunteering in Nepal. Did a road trip around Europe with some friends, and had a great time, basically, earning money and then spending and travelling. And then I finally got to university to do an aerospace engineering degree. So I started off wanting to look at cars, and then I ended up doing a Head Start course that we'll talk about later, and decided that actually aeroplanes were a bit cooler than cars because they defy gravity. So, so I went with that. But I also still like this languages theme, so I managed to do a year abroad in France, which was really good. And now I'm just in the process of finishing a PhD in cryogenic engineering, which is, again, nothing to do with anything that I started off trying to do. And I put fingers crossed because I'm hopefully submitting soon. So that's kind of my academic journey. But whilst I was doing that, I also worked for these companies, GE and Air Products, in the summers in between studies. And as well as finishing the PhD now, what I'm actually doing as a job is I was managing the Talk to Us program, which is all about public engagement and universities working with schools. So I started off thinking about the arts, then going into the sciences, then engineering, and now my paid job, as it is in fact to do with public engagement and education. So it's been a long, twisting journey. And I think that is, again, that's my big message. Don't worry if you don't have a straightforward path, because there's so many interesting things out there. Engineering really opens some of those doors.
Yeah, I'm Dennis Volkow. I'm a current student, currently studying for M in acoustical engineering. I'm in 3rd year at the moment, and again, I didn't decide that I wanted to do engineering until into A-levels. I studied physics, maths, and biology, but I did drama as an AS, and then dropped out because my dream to become an actor got replaced by the fact I wanted to do engineering. I also, as well as engineering, I do, I got into really since uni extreme sports. So I've done wakeboarding and kite surfing. There are other things around at uni, and yeah, my way into engineering is fairly similar. And I did GCSEs and A-levels and I applied through UCAS. And then you have the personal statements and the visit days and the interviews and things. And I found this to be quite helpful because it got me to see all the different uni campuses and see where I wanted to end up and confirm my sort of doubts about that I might have had about uni or where I wanted to go. The Head Start course, I did one of those, which was really beneficial for me to work out what area of engineering I wanted to go into. And the first years of engineering are normally quite broad, quite a lot of unis, which allows for change within streams, or if you want to change course and things. So even if you made a decision and end up somewhere, it's not sort of the final decision. Yeah, that's how I got here. Since uni, I've also been able to organise myself and also through the uni a few work placements, and I found it to be a really beneficial way to further my understanding of theoretical knowledge. There's not a necessity for applying, but if you have any, you can make it sound relevant on a personal statement, and that's quite a good thing to do. And in the future, I am planning on continuing with one of the companies that I work with this summer, and hopefully going to Australia with them. That's still in the process of getting organised. And yeah, what I've realised is how many different areas of acoustics there are that I could go into. I'm still not 100% sure, but there's always time, like just extend, change your mind about things. And yeah, I'm very aware that I don't know where I'm going to end up yet, but I'm looking forward to seeing what happens.
I'm going to come back to me, because what I wanted to do is actually sort of listening to what you guys who knew what engineering was and wanted to do on that, because I have a very different route. I didn't actually do an engineering degree. I might be a lecturer in engineering, but I've got a mathematics degree. And I think that's because at the time I didn't really know what engineering was. It's not something that you experience a great deal at school, because you've got chemistry, physics, your maths, biology, but nothing specifically engineering as such. So it's not, particularly being a woman as well, it's very, as a whole, a different barrier that we're working towards. But so raising awareness at a very early age is something that I'm particularly passionate about. And I think that's because, well, how I got into this though, from a completely different outside route, was because I did my degree in maths, but I ended up doing an MSc in computational fluid dynamics, which one of my passions was art. I love maths, but I also loved art. And I just saw colourful mathematics and thought, yeah, brilliant, what is that? And thought, oh, you can use that to design things, oh, that's interesting. And then my PhD was on engineering, energy technologies, and somehow got into the route through that way. So it's not all solely the same one fixed route. There are so many ways you can go into it. I don't think it any particularly disadvantaged. The skills that you get from any particular area is useful in engineering. But yes, I wanted to sort of come on to that because it's another reason why I wanted to get involved, to try and raise awareness of what engineering is. So I think the first key question is, what is engineering, I guess? So essentially, it's the application of all sorts of fundamental knowledge to try and solve real-world problems, real-life problems. So we learn physics, we learn chemistry, we learn all these fundamental things on how a process works. But how do we apply that into a real-life situation? Taking how light travels, for example, from here to there, and then seeing if we can convert it to carry out some sort of chemical reaction using that light somehow. You're taking two fundamental things you might learn in physics and chemistry, and suddenly you're building some sort of technology that could be used to convert CO2 into a fuel or something. But it's taking those fundamental things you learn at school and actually building them into a big picture. So engineering is everywhere. Okay? It's there from the mobile phones that you use to look on Facebook through to the chairs that you're sitting on right now. We don't all have the same chairs because they're all designed in specific ways for specific purposes to meet specific needs, for example. There is always a reason why we do engineering optimize our designs. So what I wanted to do was sort of give you an idea of just the fact that it's everywhere, in terms of scales as well, from designing buildings so that they not only look good, but some of them have functions, solar panels, integrated wind turbines, so they can generate their own energy, through to bridges, making sure that they not only have a function of getting from A to B across a river, but they also have certain requirements to meet, certain weights, bottleneck preventions, that sort of thing. Lots of purpose and lots of engineering goes into it, so many different routes. Cars, planes, a little bit smaller scale, but we wouldn't be anywhere if we didn't have engineering with these things. Small things we use all the time, from clickers all the way through to mobile phones, as we're saying, microwave, oh my god, that's brilliant after a delay, only when you can whack something in for 5 minutes into your microwave. Cosmetics, you get biologists, engineers, chemical engineers around the table to work out why the whole aisle in Asda is full of so many brands of cosmetics, because each one actually has a purpose. Some of them are for specific skins because of certain biological reasons, and they're engineered chemically, using chemical engineering, to actually produce things. All the way through to tiny microchips. See things like fibre optics taking light from A to B, and tissue engineering, where you can actually integrate things like chemical processes onto scaffolds and then put them into the human body, or whatever, so you can start generating and using these tools for medical purposes. And so it is everywhere. It's just you've got to stop and think, how does this work? Because of engineering, essentially. So many people have sat down and worked on it. So, yeah. So why engineering? Well, I think one of there's so many reasons why engineering. Excitement, being able to say that you've been part of a big long chain, you helped to contribute to making something work, even if it's considered a small part. That process would not be there, that whole final product wouldn't be there if depending on what your role is in there. So you helped to create that. But it's such a global subject, so a global topic, you get to travel the world, you get to meet some fantastic people and work with so many different minds. It's just amazing, really. There's so many different roles you can play in terms of engineering to play to your strengths. So you might be somebody who comes up with mad ideas and all these innovative designs and things like that. Get them on paper, because somebody will then take those designs, develop them, and manufacture them using the relevant material that they've got their particular strengths and knowledge on. Okay. What you actually do with it, how you apply it in the real situation, looking at the logistics of these things, its transport, that sort of thing. Management, how long have you got to actually plan all of this? You might have somebody who's particularly good. So I put a picture up here of just a group of our students who had looked at a wing design, high-performance wingsuit, and the team was so vast, it had skills from all of these different areas, from team management, developing it, the idea, designing it, testing it, when can we do it, and then people actually saying, look, well, what research is actually being done out there as well? Let's start with that first, and then let's build on that. So there's no one personality for engineering. You can have so many, whatever skills, there is always a role there. But then there's also the money aspect to this as well. So, next one there. Skip through. Yeah, the money aspect, because there is so much you can apply, so much skill involved. That's probably one of the reasons why engineering itself is generally, on average, about 20% higher in starting salary than other graduate starting salaries. So, always good. So, I'm going to wait for it to click over. There you go. But there are. But there are so many streams of engineering. I think that makes it so. That's one of the reasons why it's just so difficult to try and introduce it so early, because you can't pinpoint one sole area, because it is just so vast. You've got aerospace, mechanical, chemical, civil, all of these. So aerospace being aeroplanes, mechanical engineering, if things move, how they move, are they moving fluidly? Is there any interaction that's going to make them break down over time? How long will they last? Durability. Computers. making sure that you get the internet as fast as you can so you can check your Facebook. It's all good, it's all there. It's all developed by our computational engineering. Transport, so road infrastructure, traffic lights, all of that is programmed. It's not just about cars, it's all the way through to how the cars actually move on the road. Civil engineering, as we were saying, is built up structures, whether they be for appearance purposes or whether they actually have a function, what impact are they going to have on their surroundings. Biomedical, tissue engineering, electrical engineering, it's just vast, there's just so much out there. So I have the next one for Jess, who's going to put some examples to this.
I mean, some of the things that Lindsay mentioned here are some real life examples of bits of research and development and engineering that are happening in those areas, and also, like you said, real world problems that people, potentially you guys and your students, will need to solve in the future, and engineering is one of the ways you can get the skills in order to solve these problems. So I'll just briefly point out a few of them. So we've got graduation, obviously, that's a nice bit of going to university, and then next to that I can see someone's back covered in holes and rashes. It doesn't look great, but this is an allergy test at the moment. You have to be injected with every type of allergen and then seen if you react. And so a PhD student here is figuring out, can we do something else that's a bit less intrusive and unfriendly? So they're using microfluidic engineering and bioengineering to see, can we just take a tiny bit of their blood and then carry out tiny chemical reactions in there, like a miniature lab, to look for different molecules. And then that itself will have applications outside of that. I've put in a NASA concept of a blended wing aircraft because my background is aerospace engineering, so aeroplanes and rockets, and it looks pretty cool, and aeroplanes haven't really changed much in the last 50 years, but they could do. And it's the engineers that are going to make those changes. Then we've got someone in a wind tunnel. She's looking at composite materials and trying to create the most sort of the strongest or most high performance materials for sailing and yacht races. And there's a picture of the yacht there and some of her models. We've got we've got a building underneath that with a sort of heat sensor cam on there. So there's someone who's looking at say, for example, in student halls or in a building where you have people from all over the world sharing the same space, and they all have different sort of, what do they call it, sort of thermal comfort sort of situations they want to be in. So you've got the warmer rooms and then the colder rooms, and if you're aware of this, can you somehow design your building to work more efficiently and maybe even use those temperature differences to generate some energy? You've got motion sensors down below that, so we've got students who are looking at, and I'm sure most other universities have these too, we've got students who are looking at motion sensors and how that can be applied in everything from films to sport development. Yeah, wearing one right there, that was engineers that came up with that. Town planning, so there's, can you build a sustainable city? Someone's looking at, can you take linseed and use that to create a composite boat building material? And then other bioengineering projects looking at sort of blood flow and how that affects things like allergies, and even with the mice there, someone looking at maternal obesity and how that affects their children's health and things like diabetes, and which sounds like medicine, but if you need an engineer to look at the sort of fluidics and looking at the fluid and blood flow and stuff and things like that. So vast, absolutely vast. And I could go on for ages and never run out of things to say about the different projects that are available out there and problems to solve. Oh, there's some more there. There's a heat exchanger looking at thermal energy storage, and I think before you move on, a cable is going to pop up as well, yeah. So that's an example of a superconducting power cable which conducts electricity with no resistance in a vacuum tunnel next to a maglev train, which is also in a vacuum tunnel and therefore has no friction, so super high speed, super efficient transport. So these are ideas out there that people are actually working on and things that keeping engineers occupied. So just as an example of other things that you could go on to do as an engineer, this is me and a group of my course mates and housemates and friends. Actually, there's one guy there who's a physicist, so we'll just get rid of him. So we're all engineers, we all did the same course, and there's a couple of other friends that went in that picture, but got some interesting pictures of them sitting in the back garden and up a tree, you know, where you normally find an engineer. So these have all gone on to do, so all of us, apart from the physicist, did an aerospace engineering course in planes and rockets, but the careers everyone's gone on to do is vast. So, I mean, we've got one person who is now an aerospace engineer at Rolls-Royce Aero, and her story is quite interesting as well because she didn't get the grades in her offer, but somehow they accepted her anyway. And of all of my aerospace engineering friends, she's one of the ones that's actually gone on to do aero. So you are often, I mean, we'll talk about admissions later, but you're looked at as more than just grades. You're looked at as a person as a whole. So, and the fact that she wasn't written off just because she didn't get the grades, I think is a really good example. And then we've got Mariana down there, and she's got a little boat morphing to a plane because, like Geordie says, in your first year, if you have a common first year, you can switch courses. So she started off doing ship science, and then decided actually aeroplanes were cooler, as we all know is true. And so she moved to our course, and now she's working for a satellite company in Germany. She's a satellite engineer, and she also did a stint at ESA, the European Space Agency, which I think is pretty cool. And then we get slightly less engineering in, so Steve's working for BA, but he's an IT technician, so he's not actually in contact with the aeroplanes, but he's just behind the scenes doing computing stuff. Alex is now head of physics at a secondary school. She went on to do a postgraduate teaching course after her engineering degree, so she's now a teacher and head of physics. And we've got Casper, who, again, I'm not saying don't take things seriously and don't give it your all, but he did drop out after he retook his third year and decided at the end of the day this course wasn't for him. He got a job at Specsavers and is now a branch manager there. So it's just to show that you can try things and it will, so even though he didn't complete his degree, it still opened a lot of doors, gave him a lot of the analytical skills that he needed to then go on and use them, and people management skills, and that he went on to use in another situation. And then finally, Paul, who I think has got the most boring job of us all, but this might be the job for you. You know, he's an accountant at Deloitte. So it's just, there's so many options, and we'll go back to the physicist because he's got quite a cool job as well. So he's working for Ferrari F1 in Italy. So he's doing stuff with computers. I'm not entirely sure what, creating computer models for the F1 races. But so he went through physics and ended up in a more sort of engineering situation. So it's just to say, even if you're not sure what you want to do, I think, which I've never been sure of what I wanted to do, I've never managed to make up my mind, but engineering has been a really amazing route for me to open doors. It's opened more doors than it's closed, and I think you can say the same for all the people that I spent 3 or 4 years studying with as well.
Yeah, I've also really noticed that far more than I thought I would. Everyone said to me at school, and my parents and stuff and teachers, when I went off to do acoustical engineering, they said, "Oh, that's a really niche form. Are you sure you want to specify that much now?" And I was like, "Oh, I like sound, yes." And then started doing it thinking that it would help me clarify where I thought I'd realise, this bit of acoustics would interest me, and actually there's so much more variation within a niche area than I thought was possible. So all the different areas, there's bioacoustics, there's chemical acoustics and how that reacts, there's the standard sort of music and sound production and live sound. There's so much variation, and even now I've seen friends of mine, just from the nature of placements we've got or individual projects that people are doing, that they're so varied, and it definitely opens doors if you're an engineering degree, so you're not limiting yourself in any way, really.
I think the best thing to do is to start beginning. How do you actually get onto engineering, onto your engineering journey? I think it all starts in school. Having an awareness of what it is first is a good start. It sort of avoids maybe going down the back route and go really deep down like I did, realise kind of, no, I've been doing an engineering degree if I knew what it was. But the key subjects really are maths and physics, because they will teach you the underlying principles and processes, building blocks for any of these processes that are taking place basically in physics. But mathematics you'll be able to write these in a way in which you can then scale up and do something with it. So design technology, although not necessarily the primary subjects that we'd like to see when entering an engineering degree, these are, and chemistry and computing, these are skills that you will at some point be able to apply. The design technology, this is the first time really you'll be able to take some initial designs and start putting them on paper and developing them and even building small things, small structures at school. So it's the first time you actually get to apply some of this into an engineering sense, although it's not labelled engineering, so it can be quite misleading. You're not knowing what you're doing. Chemistry, probably more critical if you wanted to go into something like chemical engineering, so that probably would be flagged up as a big one for that. And computing, and as we move towards computers designing, developing and optimising all of our processes now, there is inevitably some element of coding and computational design involved, so having an awareness of computers and the underlying code that can be applied is generally introduced quite early on, so having that as an A-level is an added bonus.
Yeah, if you can get experience in coding or something before uni, I think it would be definitely beneficial. Like a housemate of mine has been working for himself from the age of 13, making computer games, and manages to make a decent amount of money from it, and is still at uni. He's the only person I know that got an unconditional offer, just because of what he's managed to do, which was he started being bored as a kid and making games of a duck that moved about, and now it's done quite well. And that's engineering, even though he wouldn't consider himself an engineer really. But yeah, he is. And so yeah, there's so many different routes and different things you can do within engineering.
That's insane, isn't it? And it'll come across as insane.
Yeah, definitely.
It makes you jump out.
Yeah.
Big stuff. Yeah, so as we say, there are so many routes into engineering. It doesn't all have to be through going through university and getting a degree. The first one obviously is school. Once you've got your GCSEs, you can then go on to either do A-levels, which would then be in your physics, maths, that sort of thing. You can go on to do an apprenticeship, which is very work-based. You can get into a job and learn as you go on the job, specifically engineering. With engineering partners and technologies. You could also go into college and learn things, you do vocational courses, where you learn things like get a HND, BTEC, foundation degrees, depending on part-time alongside what other jobs you are doing. And now these are all interchangeable. You can go from one to the other, side by side, but all of them also have access into university, okay, to some level. And at the university, that's where you will then start learning to go do either a BEng, so a bachelor's, an MEng, a master's, or even going on to research if you're specifically keen to look into exploring fresh engineering science problems that, or becoming an academic where you want to start teaching in an academic environment. But eventually, all of these will lead you to an engineering career of some degree. Okay, and whilst you're in your career, you don't stop learning. You can go for professional qualifications. You can become chartered through independent institutions, institute. And at the end of the day, it all starts at school. And even if you don't know what you want just yet, getting that fundamental physics, maths background behind you, you're onto a winner to kick start. What you can actually do whilst you're in school, at this level, at this age, is you can start exploring doing some research really, asking questions is the best way to do it. So you've got various people you can ask, so you've got teachers, you can ask them questions, you can inquire about Head Start courses, which you guys will talk about afterwards. Career centres gives you an opportunity to go and ask questions, do a bit of research based on what they have, and they can point you to various sites for more information. Extracurricular activities, and this gives you an opportunity to look at engineering problems. I knew somebody who decided when they were 14 they were going to rip to shreds the father's lawnmower just because he wanted to know how it worked. And this sort of stuff comes across, and it sounds like really inquisitive. But it's not just, all these extracurricular activities don't necessarily have to be engineering based. It could demonstrate soft skills like management, time organisation, people skills. But there's also the library. Don't forget that there are still libraries out there. We might have the internet to our hand now, but libraries are fantastic resources for various textbooks and information that you can flick through and get an idea of what these courses might entail if you do proceed further. But yeah, the internet, it's there. We've got so much knowledge at our fingertips. We are so lucky. I didn't have all of this all those many years ago. But there are so many sites as well. I mean, I've just listed Tomorrow's Engineers, the Institute of Engineering and Technology, you've got the Royal Engineering, Academy of Engineering. There's so many out there that can give you so much information about how you can get into engineering and what you can do to kickstart all of this. But if you do any of this, all of it is so valuable to stick into something called your personal statement, which is what you would need to get into a university if that's what you really want to go on your UCAS forms. Showing that you have inquired, you've developed an interest by looking into things and asking questions and doing this extracurricular activity shows how keen you are to get onto this course. So yeah, I figured I'll sort of close off my bit with how you can actually engineer your personal statement and strengthen it in such a way that you can distinguish yourself from all of the other candidates who might be going for these roles. And because we process, for just us alone, there are so many universities across the UK who do engineering, but we process hundreds and hundreds of personal statements and see so many candidates every year. So it's a personal statement that makes you stand out. So how you can tailor that. So there are some things to include which will really help strengthen it. So if you do any work experience, extracurricular experiences, get them in there, okay? Just what knowledge have you applied? Don't just say it, but what did you actually learn? Have you demonstrated teamwork? Are there any key management skills that you've managed to pick up on the way? Time management, organisation, that sort of thing. What relevant skills have you applied? So have you dismantled stuff, put them together? Why did you do that? Were you keen, or did you have to? It generally didn't work and I needed it, sort of thing, but found, oh, that's quite interesting. Have you ever written a piece of code? All this stuff makes you stand out because you're already demonstrating that you know you need to go explore to get the answers to things. Even if it's just sketching new ideas and designing them on paper, you might not have actually physically built it, but you're already thinking, how can I make that better? Something. Plans for the future. So what do you want to be in terms? If you know, fantastic. What do you need to do to get there? Yeah. If you have an ambitious streak, it's actually quite a good thing because if you already know what you want to do, you're going to drive to push yourself to get there. So additional research. Have you got any favourite engineering books? Have you got any non-engineering books that might be interesting? Because I had a chat with one of the prospective student a couple of years back, and it fascinated me because she said to me, I'm mad on Harry Potter. I'm so mad, I've read them all. She went, well, it got me thinking, they've got all these different broomsticks. How do they know which ones to use? Right? Surely some of them are faster than the other ones because of the way they're designed. And I just thought, she's thinking about Harry Potter in an engineering way. This is brilliant. And it's that kind of thing that makes you stand out because you are already thinking like an engineer. Okay? Elaborate on it. Don't just say, explain the impact. Yeah? So how you would actually write it, generally, you're finding this all over the internet, I thought I'd summarise a little bit. But generally the first paragraph is your motivation. It's the one that's going to stand out. Why do you really want to do an engineering degree? Second and third paragraphs, this is where you get the chance to actually provide some of the information of what you have done and how it's relevant to what you've done. And the third one will be the various transferable skills that you've picked up on the way. So all the stuff on the previous slide would slot in quite nicely into your structure. Now, when it comes to the personal statement, obviously getting onto university degrees, you'll be given offers a bit of grades of which you want to achieve. But I cannot stress enough how important the personal statement is, because if we have to distinguish between students it is the enthusiasm that we want. You might get 2 students with 3 A's, 3 an A star and 2 A's coming through our door. But if one says, I've been wanting to do this for years, I was developing Lego from the age of this, that and everything, developing things using Lego, and I was constructing a lawnmower and this, that and everything else, then you've got another one saying, yes, but my dad says I should be an engineer. I know which one I'd like to go for. So it's really important. I can't stress enough how much time should be spent on personal statement. So I'll pass over to you guys, and you can talk about Head Start.
So there are loads of different ways to find out what engineering is, because, like Lindsay said, it's not taught in schools. Because it's too vast, it's hard to pin it down, and it's quite often something you need to experience as well, rather than just learn about or read about. So I said, I first thought about it because I got this bee in my bonnet about sustainably powered car, and it was because I read some poster in our school corridor about someone who discovered how to recycle mobile phones, and I was thinking, they've taken something that previously been said was unsolvable, a problem that no one could solve, and they've done it. That's pretty cool. Wouldn't it be cool to be that sort of person? And so that's why I thought about the cars. And I went to my physics teacher, and he sat me down and told me about a Head Start course, which is run by the EDT. There's a website up there. I think they do a few other courses at different stages. So this is when I was doing AS level, AS levels. And I signed up for one, and there was funding available to go as well, which was good, because I came from a background where there was no money to send me on any of these courses or anything, but there was funding available, and I went along and learned about all the different types, well not all the different types, but learned about a range of the different types of engineering. I was there with other sixth form students, and we stayed in Imperial College for a week, and we also got to go out to the cinema and go on the London Eye and stuff like that, and then we went into labs and workshops. We got to build a little cantilever bridge and a little radio and a few lectures, and experience what halls were like and what the university campus was like. So it was a really, really valuable experience. And then I've also put up the WISE website, or in Science and Engineering, which is an interesting one, because science and engineering have often been perceived as well. They've been male dominated, or male, I don't like the word dominated. There's been more boys doing it than girls for a long time, but there have never not been girls and women being absolutely fantastic engineers, from Ada Lovelace, Emily Warren-Roebling, all the way through to like half the team that put the Mars Curiosity rover up in space and everything. And that's a whole other presentation, but literally. But what happened was, when I started looking at courses and looking through like university prospectuses, and I was looking at everything from geology to engineering and everything in between, and I started just calling these admissions tutors numbers and saying, hello, I'm interested in your course, can you tell me more about it? And everyone was really friendly. And at the University of Bradford, I think it was, I was talking to someone over the phone, and she said, oh, in a few weeks' time, we've got a WISE weekend course, so run with women in science and engineering. We're getting loads of female A-level students to come and see our labs, come and have a taster session. Why don't you come along? There aren't any spaces left, technically, but we can squeeze you in. So I went up to Bradford to do that, and yeah, it was brilliant. It was just like the Head Start course. So Head Start, definitely recommend it, but also there are other options as well, like WISE. Most universities have an outreach team where they run similar courses. Everything from a one-off evening drop-in session of sort of speed networking or meeting engineers and lectures, all the way through to week-long residentials. So contact university admission teams, go to the university outreach web pages, see what's local to you, and get a taster of it.
Yeah, definitely. Things like Head Start and summer school were really good things for me, especially because I was told about it. I sort of was interested in science and technology, and again was told by, I think, a physics teacher, oh, go and do Head Start. They sort of told a lot of us that were doing engineering-based A-levels. And I was with a friend, I remember he was wanting to look at geophysics, and I wanted to look at acoustics. And there was no courses on acoustics, but I thought, oh, I'll go and do it anyway. I'll try something else that I hadn't really heard of, and I'll see, maybe I want to do it. So I had a look, and I found systems engineering, which I thought would be, in my head, it was going to be really good, and like be a holistic view of engineering, which it was. But what I realised is that I really didn't want to do that as much as I wanted to do the acoustical engineering or mechanical engineering, and that helped me sort of confirm doubts that I had, which was really beneficial for me. And also it was a chance to experience like uni life and sort of electricals a little bit. I went up to Loughborough, and it was definitely a good experience for me in A-levels.
Okay, so thank you very much to our panel. What we would like to do now actually is open up the session to your questions. So we haven't had any come through whilst we've been talking, that's absolutely fine. But what I'll do is I'll mute our microphone, and I'll just give you the opportunity to ask any questions that you have to ask. There's the questions panel in the control panel for you to ask those. So I'll mute it and just give you an opportunity, and then I'll ask them out to the panel, and then everybody can hear the questions. Okay, so I'll give you a couple of minutes to do that. That would be great. Thank you. So great, so thank you very much. We've had a couple of questions come through. The first one is, this is a really good presentation and they'd like to share it with STEM students. That's from Janice. Yes, this is being recorded right now, and I will make it available for you on the website. I will email everybody out as soon as the recording is finished, so at some point this week. So yes, you can share it with your students, that's absolutely fine. The second question came from Adele. There's a question here. Are there many degree apprenticeships that you are aware of in engineering? And
yeah, I just realised I completely didn't talk about this because I'd forgotten that I applied for this because I was talking about how I got to uni. But before, or as well as uni, when I was applying for UCAS, I also was really I was wanting to not go to uni and do a apprenticeship with the BBC in broadcast engineering, where you work for them for 3 years and in partnership with working, you sort of, it was with a couple of, I forgot which uni it was, I think it was Birmingham, and you gained a degree as well in broadcast engineering. And it was fully funded by the BBC, you were paid as well. And there were a lot of applicants. I got down to, I know I was the reserve choice, and I wasn't successful. So I came to uni instead, which I'm really pleased about now. And actually, the contact at the BBC, I got sent a really, really long rejection email. I was focusing on the phone. He gave me a contact of his friend at Sky, and that's how I got work experience at Sky. And just even so, the whole experience for that was so beneficial for me, because everyone I've worked for since then has been quite small companies that I've just emailed kind of thing. Whereas this was a really big application process with like long written answers. But definitely there are apprenticeships out there. There's just so much they're harder to find, but they do exist. But if they are fully funded degree programs, they tend to be quite sought after. I think it was 2,500 applicants for 12 places. So it was quite a few. But it was really, yeah, there are definitely good options out there.
Probably a really valuable lesson. I think we've mentioned a few times that sometimes finding out something you don't like or something that may not feel like being successful necessarily is a really valuable learning point. And learning that I've learned from my PhD, which I went and think it would be an engineering PhD, and it was quite an experimental physics PhD, and I loved all the engineering side, all the wiring up and the setting up the experiments, and the actual experiments stressed me out. And so I've learned a really valuable lesson there, which is that I'm not an experimental physicist, but I think I'm quite a good engineer, and so you can, every experience is a learning point, whether it's what you expect it to be or not.
Yeah, definitely. I've been learning about research at the moment with my third year projects, because I quite liked all the code stuff in first year and second year, so it's quite a coding-based signal processing type project looking at acoustic emission of knee joints and trying to do pattern recognition on that. And what I've decided is that I can do coding when it's an assignment that says, here's the questions, but researching it myself to sort of come up with the best way that I think has been a lot more challenging. And I've sort of, it's just stagnated and I don't know as much about what I'm doing anymore. And it's a learning curve, so engineering is great. But yeah.
Okay, so thank you very much. So the next question is a bit of a lengthy one. This comes from Jackie, so it's a scenario that she's found herself in. So Jackie is a careers advisor who met with a Year 11 student in school today who's interested in engineering. He's thinking of studying maths, physics and chemistry. I assume that's A-level, yeah. But is concerned that that may be too much. So he's considering history instead of chemistry, but knows it will exclude him from chemical engineering. He's currently interested in aerospace or chemical engineering. Any thoughts? So there's that, you know, moving out the chemistry for history.
Yeah, so I think we do, so I do mech admissions, mechanical engineering, but we're also quite aligned with aerospace engineering as well. That combination of history should not be an issue for aerospace engineering because the fundamental subjects for that would be maths and physics, which we still have. But for chemical engineering, we don't have that here, so I don't want to solve, I don't know what other universities might have in place. But I can imagine it would be something that if they have particular universities on hand, maybe have maybe phone the admissions teams there to make sure that they would be able to give more specific information in that case. It would be difficult from our end to specifically comment on that one. But admissions teams should be, as come across, getting in contact with them, very approachable and very amenable to answering any questions well before this process even takes place. So these are the kind of things that they want to hear and we'll be able to help with. But yeah, I think that seems the same.
So for aerospace, if aerospace was the route you wanted to go down, definitely the history might be seen as beneficial because the amount of essay writing skills and things that it would teach you. So when you have a 10,000 word dissertation to write, you've written essays before and you know what you're doing a bit more than had you not done essay-based subjects.
It's nice, depending on personality, but I found it was good having a balance. So I did maths, chemistry, physics, and Spanish as well, and the maths and the physics really complemented each other, and I'm not sure I would have enjoyed one as much without the other. Yeah. Chemistry, I was really lucky, I had amazing teachers, and I just found it really interesting. But I think if I'd just done those three subjects, then I don't know, it's nice to have a different perspective on things sometimes and a different learning style, so having something a bit, I was going to say creative. The thing is, engineering itself, especially when you get to university level, is very creative. Like, people think because you're restricted by these limitations of the materials or the problem in front of you that it's not, but actually that forces you to be more creative. But I guess when you're at A level, sometimes it can feel maybe that the physics subjects aren't so creative because you're just learning principles. But having something like Spanish where it was just a different way of learning helped for me balance it out. Of course, you might suit one way of learning or another, or one subject or another. It's all down to the individual. But it is possible to do maths, chemistry, and physics and survive. But it is also nice to have something else. Yeah,
I was the same. I had drama there, which was something that was literally there because I enjoyed it and I knew it would. Well, it was there as the fourth AS, but it was really good to have. So the same as well with biology, I had two sort of maths-based physics and maths, and then biology was a lot more, a different way of learning things, a lot more sort of based on, there were longer answer questions in the exams, and I found that really useful because it's something I just could foster a passion for and an interest in.
Okay. So next question, I'm not 100% sure whether you can answer this, but can someone with use of maths A level enter to mechanical engineering? I'm not sure if that's something you want to commit an answer to today.
I'm assuming they haven't got physics by that question. Maths is one of the key ones, physics being the other one. If physics is there, then there shouldn't be an issue, as long as they've achieved the grades for the offer, and if not, really put something into their personal statement. it's tricky without knowing whether or not they've got the physics as well, because the pair go hand in hand. And those two, so we have seen that it's much easier for students to pick up very early on if they've got those underlying.
Oh, sorry, so they responded, yes, he also assumes as a student, yes, the student also does physics and engineering.
Yeah, I would assume apply through the usual UCAS method, they'll hopefully receive an offer based on the application form, and as long as they achieve what's needed, then it should be fine. Maths and physics being.
Yeah, and so if is your advice, if there are any uncertainties, the best thing to do is to contact admissions directors.
I mean, like I said, we're all open to answer as many questions as you've got. So,
and would you suggest that they contact more than one admissions tutor? Thinking about the number.
Yeah, if they know what course they want to do. So if he wants to do mechanical engineering, try a load of mechanical engineering departments. Ask questions to various different courses. It doesn't have to be specific universities. The more you can get, the more feel for the grades required, what's needed basically to get onto those courses.
Okay, thanks very much. Yeah. So next question, again, is more of your thoughts and opinions. I'm not sure if you are in a position to answer this one, but what are your thoughts on the comparison of engineering delivery between sixth forms and colleges? So I'm assuming that's looking at the delivery of sixth form, delivering in sixth form schools, and contrasting that to colleges, and whether would that be something you'd be aware of yourselves?
I have people that went to college, a lot of people, friends of mine and things that went off to college or did apprenticeships, definitely got a more practical understanding, were doing more practical things at younger age. When I was doing theoretical physics and maths at A level, they were either working or applying things, but I think it doesn't limit options as such, but they were working in one specific area, and I don't know, I think they knew what area they wanted to be in, but I think the delivery is typically more practical at colleges, but I think it depends on what you are studying at the college. But yeah, I think my housemate's doing physics now. I did A levels in physics and maths, but I think at GCSE did a diploma in engineering, so I think there are other options there, but I'm not that sure on what they are.
It depends on the individuals as well, because some of them might want to pick up in a work-based, college-based, hands-on environment more than sitting in front of a blackboard taking down notes and equations as well. They go through the sixth form route. But the levels at which you can go to, all of them can access, provided they've got the right prerequisites, they can get into universities. So I would say, and even if they don't, so something I haven't mentioned as well is, even if they don't have that maths or that physics specifically, there are other routes in, so we can do, well we do, a foundation year just as an additional top-up to get you up to speed so that you could join in and do. It's just one additional year on top of it. So in terms of it's there's so many different routes.
Yeah, a friend of mine I was studying physics with him in school, and he, after first year of A levels, just decided school wasn't for him, and he learned practically and went off to college, did engineering, as a BTEC I believe, and an apprenticeship, and I think he's now finished his apprenticeship and ended up, through like the placement he was on, he worked really well with the team there, and he's now working for a big tool-making firm, I believe, and he's really enjoying what he's doing, and it meant that he's been earning money for a while now. He's been working practically, doing things that, talking to him now, I've been learning about, and he's definitely an engineer, but he didn't go through the university and A-level routes.
Yeah. Great. And then another question. Do many fields in engineering require coding skills? And is it a problem if you have no experience in this?
No, it's not a problem.
No, I can't imagine it would be a problem, because at an early stage of their career anyway, they're taught this from very early on in the degree, from the basics up.
Yeah, the thought of coding really scared me. I remember walking around unis in my mum and being like, I don't think you want to do computer science. And she sat at the computer all day, and I was like, yeah, I know. And when I started learning it, suddenly something clicked with me, and I found it really interesting to learn. And like I say now, I had no experience before uni at all in coding, and now I've ended up actually really liking it, doing well in the coding modules and picking like projects based on one that used a lot of coding, which I didn't think I'd do at all. And so yeah, no, I wouldn't say it's an issue at all. But if you now you want to go into engineering, I say definitely if you could get experience in it, it will teach you. It'll be pretty invaluable. It's similar to learning CAD software. I didn't know how to use that before, but using it, having learned how to use it before would have been really useful. But it's not a prerequisite.
A lot of things about coding is it's just logical statements, which is what if you like engineering, that's what you're
it's like
fine-tuned to do anyway, really, a bit of logic. And it's most of it's just learning the syntax, learning how you get it across. It's the same principles. A for loop is a for loop.
Yeah.
How you write it might change, but it's just learning that you get the practice, as with anything. Really.
And you do get that opportunity at university.
Yeah.
So I didn't know coding at all before I started, and then there were modules looking at the different ways you can use it, and quite often do a little bit of coding, even in data processing software and stuff now. I feel much more confident. I feel after a little bit of tuition at some modules in it at university, I feel confident enough to use it. So.
I definitely did this math degree. I didn't know at all.
Yeah.
So my PhD being writing a massive piece of code was like first 3 months. But no, you get it.
after my first year with here's a for loop, here's basic sort of syntax in Python. A friend of mine was working at this company that went down sort of UI, and I ended up trying to write software for them, which I did, and it's a very ropey written piece of software, but it automates material testing of optical fibres. And I didn't think I could do that. And when I was doing it, I didn't know what I was doing, but because it's a learning curve, you can try things, and if it works, it's like, oh look, now this gives me, I had to program a graphical user interface, which I'd never done, didn't even know what it was. And because of the way computers are nowadays, everything's online with Stack Overflow, because it's an online type computer-based thing, the amount of information there is ridiculous, and it's something that you can very easily pick up.
Okay, great, thank you very much. So there's no more questions at the moment. However, we have about 8 minutes, so if anybody does want to send in a question, we'll give you a few moments. But just before we go, what we would like to do is just to get your viewpoint on today's session. This will just help us with any sessions that we might do in the future. I'm going to launch 3 different polls. It's multiple choice, and if you could just select the option that's most appropriate, then that would be great. So you should see the first poll now. And the first poll says, this session has increased my knowledge of the topic. If you could all fill that in for us, then that would be great. I'll give you 5 more seconds. Okay, and I'll leave that there. I'm going to close that now. And then I'm going to launch our second poll. And this asks you, the information will be of immediate use and will inform/support my current practice. So again, if you could just tell us your views on that, then that would be fantastic. Okay, and I will give you 5 more seconds. And I'm just about to close that one. And then the last poll. This session has met my expectations. If you could select the relevant answer, then that would be great. I'll give you 5 more seconds. And I'm just about to close. Okay, so We don't seem to have received any more questions. So what we'll do is we will mute the mic and we'll stay around for the next 5 minutes. If you do have any questions, please feel free to send them in, and if not, you are more than welcome to sign out. Thank you very much for joining us today. As I mentioned, this has been recorded. We will make it available online, and please feel free to share to your colleagues, if you're a student, to your peers, to your parents, to anybody who you feel might find this informative. So thank you very much.